program Education Online. I am teacher Akena Patrick Omoy, a teacher of physics. We are going to have a lesson with the topic lenses and optical instruments. That is for learners in senior 4. Dear learners, for our today's lesson we are only going to concentrate on lenses. But before we concentrate on lenses, we also have to know something about optical instruments. Now for the introduction, say optical instruments are devices that changes the visual angle. So optical instruments are the devices that changes the visual angle. And when we talk about visual angle, we mean the angle that is subtended at the eye by an object. So optical instruments are these devices that will always change the visual angle. Visual angle means the angle from which we view an object. And when we look at an object, the object will be looked at certain angle. And that angle, we call it the visual angle, the angle that the object subtends to our eye. Now the examples of these optical instruments that we shall come and look at them in details are: one is the camera. A camera is one of the optical instruments. We shall come and look at the camera in detail. 2, we have the telescope. We shall also draw and see how the telescope forms an image at various angles. Then we also have periscope. So these are some of the few examples of optical instruments. Dear learners, today we are going to look at the lenses only. Then in our next lesson we shall also look at these optical instruments that we have named. So today we are looking at lenses. Dear learners, what do we understand by lenses? So we have in our homes, we have things like the spectacles that people put on, the eyeglass. So the eyeglass that people put on is made of a lens. A lens can either be made of a glass, it can be made of a plastic, or any other transparent material. So now, to define lenses, we say lenses are spherical surfaces of a transparent material. So lenses are spherical surfaces of a transparent material. When we talk about the transparent material, we mean the materials or a material that allows light to pass through. So when a ray of light is incident on these surfaces, which means the light will be able to pass through the material. Now, these spherical surfaces can either be made of glass, it can be made of plastic, and also water. water can be made to form a spherical surface. So all these materials can form a lens. Now we have examples. So we have types of lenses. So let's look at types of lenses. Now in physics, we have two major types of lenses. There are two major types of lenses. One is called the convex, or it can also be called converging lens. We can either call it the convex lens or we call it the converging lens. Then the second example of lens that we have is the concave, which can also be called the diverging lens. So these are the two main types of lenses that we have. Now, dear learners, let's look at these two types of lenses one by one. And we are going to begin with a convex lens. And we shall also see why a convex lens is called a converging lens. And we shall also see why a concave lens is called a diverging lens. So one, we are starting with convex lens. Dear learners, what do we understand by a converging lens, or what is a converging lens or a convex lens? So this is a type of lens that is thicker in the middle than at the edges. So the nature of convex lens, it will be thicker in the middle than at the edges. So this is how a convex lens appears. So a convex lens is divided into three. It is divided into three. One is called the biconvex lens. And this is how a biconvex lens looks like. This is a biconvex lens. Just from the definition of convex lens, it is a type of lens that is thicker in the middle than at the edges. Now, looking at this lens, we shall find that in the middle is thicker than at the edges. So at the edges, it is thin. It looks thin at the edge. Then in the middle, it is thick. Since I said they are divided into three, which means the first type of convex lens that we have appears like this. Then, still, the second division of convex lens is what we call the convex, or we call it the converging meniscus. Convex or the converging meniscus. Now, how does the convex meniscus or the converging meniscus appear? So this is how it looks. So this is a converging meniscus, which is still another division of the convex lens. Again, it is thicker in the middle than at the edges. Now, dear learners, when you look at this converging meniscus, you'll find that it is thicker in the middle than at the edges. When you look at the edges, they are thin. Then it is thick in the middle. Then the third division still of convex lens is what is called the plano convex lens. The plano convex lens. So this is another division of the convex lens. Now, dear learners, how does the plano convex lens looks like? The plano convex lens is half of the biconvex lens. So this is biconvex lens. When we divide it into half, when we divide this into half, it forms what we call the plano convex lens. So this is how it appears. Just like letter D. So this is what we call the plano convex lens. So as I said, a convex lens is the type of lens that is thicker in the middle. So you can also look at this. It is thicker in the middle than at the edges. Now, why do we call convex lenses to be converging lenses? Why do we say convex lenses are converging lenses? They are called converging lenses because all rays, we shall look at rays that will be falling on this lens. All rays that will fall on this type of lens will converge to a point, meaning they will come and meet at one point, that is after refraction through the lens. It is because rays that are parallel and close to the principal axis, is because rays that are parallel and close to the principal axis will converge to a point called the principal focus. After refraction from the lens. After refraction from the lens. So we shall look at the principal focus and the principal axis when we come to the ray diagrams. So they can ask you, dear learners, why are convex lenses called converging lenses? It is because rays that are parallel to the principal axis will converge to a point called the principal focus after refraction from the lens. When we talk about refraction, we mean as rays of light will fall on this lens, it will change its direction because the optical density of the lens and the medium from which the light is traveling will be different. That is, a lens will always be more dense than air, since light mostly travels from air to another medium. So this is the reason why we call it the converging lens. To converge means to come and meet at a point. We shall look at this when we come to the ray diagrams. So dear learners, let's also look at the second type of lens, which is the concave lens. And we said concave lens is also called the diverging lens. We shall also see why we call concave lens to be a diverging lens. To diverge means to spread away from a point. So the second one is the concave lens. Now, dear learners, what do we understand by the word concave lens? So this is also a type of lens, that is thicker at the edges than in the middle. Dear learners, don't confuse this. Convex lens is thicker in the middle than at the edges. Then concave lens is thicker at the edges than in the middle. So this concave lens is also divided into three, just like we have seen the division of the convex lens. So it is divided into three. So let's also look at the three divisions of the concave lens. One, Roman numeral 1, we have the biconcave lens. The biconcave lens. Now, dear learners, how does biconcave lens looks like? So this is how it appears. So this is a biconcave lens. Just from the definition, it is a type of lens that is thicker at the edges than in the middle. So when you look at this, you find that it is thicker at the edges than in the middle. Then the second division of the concave lens that we have is called, that is Roman numeral 2, is called the concave, in bracket, diverging meniscus. Concave or diverging meniscus. So dear learners, how does the concave or the diverging meniscus appear? So this is how it appears. This is how the concave meniscus appears. So just from the definition, we shall also look at the diverging meniscus is also thicker at the edges than in the middle. So from here, when you look at the edges, it is thicker than in the middle. Then the third division of the concave lens is called the plano concave lens. And plano concave lens is also half of the biconcave lens. Now, if this is the biconcave lens, if we divide this biconcave lens into two, then half of it forms what we call the plano concave lens. That is the third division, plano concave lens. And this is how it appears, dear learners. This is what we call the plano concave lens. Looking at it, it is thicker at the edges than in the middle. So these are the three divisions of the concave lens. Now, as we said, the concave lens is also called the diverging lens. Why do we call concave lens to be a diverging lens? The reason is because rays that are close and parallel to the principal axis, will appear to diverge, or in other term we can say come from, to diverge from a point called the principal focus. The principal focus after refraction from the lens. Now, for a concave lens, we call it diverging lens because rays of light that will be incidence on the lens will appear to be coming from a certain point that is called the principal focus. So if it just appears to be coming from that point, which means it is not real, but it looks like it diverges from a point. So we shall also come and look at the principal focus of the two types of lenses, which means this one which appears to be coming from a point is not real. So the principal focus will be negative always. It will be in the negative direction since it is not real. So dear learners, you can be asked, define concave lens. Then they will draw any of these three. They say name the type of lens shown in the figure. So which means you need to know how a biconcave lens appears, how a diverging meniscus appears, then how a plano concave lens appears. So dear learners, we have been using words like principal axis, principal focus. Now let's see how rays will be refracted when it is incident on a surface. And looking at those, we shall also have some terms that are very important when we are dealing with lenses. And we can only understand these terms when we have a clear picture in mind of how the rays will be refracted from the lens. Now, terms used in lenses. Terms used in lenses. Dear learners, for us to understand these terms, we are going to pick one of the type of lens. Then that we see how rays will be refracted in that. Now when we take a convex lens, so this is how a convex lens appears. So a ray of light, so there's a line that is passing through the center of the lens, and this line we call it the principal axis. So this line passes through a certain point in the center of the lens, and this point we denote it with letter O, which is called the optical center. Then at the end of the lenses, we call it the poles. So this is the pole of the lens. Also at this point is also the pole of the lens. Then along this principal axis, we have a point where rays will converge to. And this point we call it letter F, which means the principal focus. Now, as rays of light will be falling on this lens, if this is a ray, this is the center of the lens. Now, if a ray of light falls on this lens, so when we look at this ray, it is parallel and it is close to the principal axis. When it reaches the center of the lens, this ray will converge to a point, that is, it will be refracted. So when it is refracted, it will be able to pass through the principal focus of the lens. What if we have another ray which is still close and parallel to the principal axis? So this ray also, when it reaches the lens, it is also going to be refracted, and it will be refracted to pass through the principal focus. But these are not the only rays. There can be as many rays as possible. All will be refracted through the principal focus. They will all be refracted through the principal focus. Then the distance between point O, which is called the optical center, and the principal focus, we shall denote it with small letter F, meaning the focal length. So keeping this in mind, it will help us to understand some of the terms that we shall be using when dealing with lenses. So now the first term that we have is called the principal axis. Principal axis. Now looking at our drawing, the line that passes through the optical center and the principal focus is what we call the principal axis. So we define principal axis as a line passing through the optical center, and optical center we denoted it with letter O, passing through the optical center and the principal focus. Principal focus of the lens. Focus of the lens. And principal focus, we denoted it with capital letter F. So when you look at this line that passes through the optical center and the principal focus is what we call the principal axis of the lens. Then the second term that we have to also know as we are going to deal with lens is called the pole of the lens. Pole of the lens. And pole, we denote it with letter P. Now when you look at our drawing, this is the pole of the lens. Now what do we understand by the pole of the lens? So this is a point. This is a point at the center of the lens. So now when you look at the lens, from this to that point, you find that the midpoint is this, which is the center. So this point is what we call the pole of the lens. So dear learners, there are still so many terms that we shall continue to look at when we are dealing with lenses. So for today, I would like to end here. Thank you for attending the lesson. I hope you enjoyed it. I'm teacher Kena Patrick Omoy. Bye-bye.